Hi everyone, welcome to Module 9.1. This is about systems development. This is again the Information Systems Resource Management, IT240 at Hofstra University. In system development, what we're really concerned with, we want to look at the progression of how systems are developed. We're going to take a brief look at programming languages. We're going to try and understand some of the complexities associated with development in general. Basically, we'll give you some of the terms so that you can understand it. Most managers, if you're not in IT, may not need to know all the specifics about it, but it's a good idea to understand it. So if you're working with IT, you might be able to understand some of the complexities that are around the decisions that are made and why certain things are the way they are. For example, why do we use Java, or what is object-oriented programming? Why do people, IT managers, make those types of decisions? So this will tie in a lot of those concepts. So developing systems is not an easy job. I can tell you from personal experience, and for those of you who have been in IT, you know this. If you get requirements, basically, and you're starting to go through the project, if anything can go wrong, it will, and it does. And sometimes it goes horribly wrong. That's not to say that the programmers were bad or the project management was bad. It could be a combination of factors, including external factors such as we don't necessarily think the project is going to be valuable anymore, or the business wasn't necessarily clear on the requirements. So as you started developing and started prototyping, we find that the product wasn't what the company really needed. So there's a lot of reasons for these types of failures. Through the years, there's been a progression of building systems. In the 1970s, we came out with this concept of the software development lifecycle, and we'll explore a few of those paradigms. In the 1980s, we started to get more friendly languages and automation of certain parts, such as code generation. You'll see things like automatic code generation or computer-aided design, CAD and CAM. Those appear in the 1980s. Databases emerged quite readily in the 1980s as well, making it easier to retrieve data without complex programming. That's not to say some of these programming languages weren't out there earlier. They were just very cumbersome. So the first programming languages were like Fortran, and then the first business language was COBOL. And these were languages that made it a little bit easier to program, but you still needed to be a computer scientist to actually code them. In the 90s, we had increased reliance on third-party packages, so now we're focused on buying applications, or buying applications that will help us maximize our return and minimize the amount of development that we need to do. So this is where we start getting into the concept where we no longer necessarily need our own IT shop. If we're good, we might be able to find off-the-shelf packages, or we might be able to even buy components so our IT staff can actually do things a little bit quicker. So what we also find is this concept of business process re-engineering. A lot of talk in the 1990s of re-engineering the business processes to better fit the technology. The reliance on this was around integrating systems. So you find that ERP systems begin to emerge more readily. These are third-party applications or packages that basically allow us to integrate finance and logistics and marketing departments, our Salesforce, inventory systems together in a single package. And so we would have to re-engineer our business processes to ensure that all of these pieces work together nicely. In the late 90s, we obviously saw the internet boom, so now everything needed to be web-based. So, did the original programming paradigms work? Back in the late 90s and even mostly late 90s and a little bit of like 2000, 2001, you could get a 15-year-old developer if they knew how to turn on a computer. People were writing $90,000 checks to these kids to basically develop a web page because they didn't know how. And this was the paradigm of if you build it, they will come. So as long as you had a website, that's all you needed because it was the new economy. And that turned out to be entirely false. The internet emerges more in the 2000s as well as mobile technologies, and we have faster development, but we also see the emergence of newer languages that help aid in that development. And as such, we find that the programming becomes more modular. We try and put things together a lot quicker. And so internet programming takes on a new life of its own, if you will. Even though some of the paradigms still held, we find new paradigms emerging, well, a little bit more stringent, such as Agile and Scrum. Today, almost every application is a network application. You cannot find an application, really, that doesn't have some sort of networking component. You still have things like Microsoft Word and Microsoft Excel, but you can always find pieces of them that will connect, let's say, for help. So as long as you're connected to the network, you can get it. Those are known as thick applications because the entire application resides on that computer. A thin application is one that's very, very small. Like a browser, it doesn't have a lot of functionality, but it connects to a server so that it can add functionality and do the business process that you need it to do. The web-based applications were the first generation of this internet-centric computing. And what that basically means is when we were doing web pages and using JavaScript and other things associated with web programming, it was a very, very dynamic type of environment where the web page would go to the server, or the request would go to the server, it brings the page, and it then does some work. And later on, we find we're trying to put more into the client, and you'll see the concept of a rich internet application. For those of you who are familiar with either Flex or Silverlight, and if you're not, I would recommend that you go to Adobe Flex, adobe.com, and look at Flex and some sample applications, and you'll see how it can do more. It's a richer experience than some of the basic web pages. We do try and mimic that in some of the web pages that you're more familiar with things like JavaScript, something called Ajax, which allows us to add additional functionality, make it feel a lot better. But it's fundamentally different, especially because of what Flex and Silverlight can do. In addition, we really focused on a lot of interconnectedness, especially with regards to our supply chain. So we would want, if we're any type of large organization, to really interconnect with our suppliers and make sure that we can track every piece of inventory, raw materials, all the way from its pulling out in the earth, all the way through to its final manufacturing and even up to the retail, to the final sale. One example of this is Walmart. Walmart has done an excellent job of basically piecing all these things together, not necessarily at the raw materials, but from their distributors, and knowing where every shipment is and what store it's going to, and basically who buys those products. They're very good at understanding that. So in the early years, this was considered a craft. You kind of were a computer scientist. You knew what you were doing. You went to college for a degree, and it was a very, very structured environment. And what you'll see is a waterfall approach, which is on the next slide. And basically, the way it worked was you got your requirements. Once everything was done, you went into the additional software requirements. You did some validation. You then went to preliminary design, and you may have this iterative approach going back and forth, but the reality is it went from one stage to the next stage all the way out to the final deliverable. The problem with this was, this is great in concept, it doesn't really work this way because it takes too long to do. By the time you do the requirements, things may have changed, or you may have realized certain things have changed in the first phase, and by the time you get to implementation, you may not want everything that you originally said maybe a year ago in the requirements document. So the waterfall method has some pitfalls to it. It would be nice and almost utopian if we get the requirements right on the first shot, but that really doesn't happen.